Hello, everyone. Welcome back to SAT Math Question of the Day. Here's our question of the day. Please give it a shot. Pause the video, come back, and we'll do it. Okay, what are the solutions to the given equation? Oh, interesting. What are the solutions to the given equation? Boy, it seems like there's a quick, clever way to do this, but maybe not. Maybe you just do
There's
it.
always a I see one.
You do? Well, while you do the quick and clever way, I'll do the
You
slow way.
want to think of it independently? Me telling you my thoughts.
Tell you what, let me just do it the slow way. See how fast the slow way is. Now this x minus 2 squared, we could just change this to x minus 2 because this is a negative. 2 minus x is the negative of x minus 2. So we could just do this. So that's easier. X squared minus 4x plus 4. And now this is sort of a stupid way to do it. I mean, I'm doing it. We subtract x. So it's x squared minus 5x. Add 1, add 1, add 1, plus 5.
Yeah.
So then it's not this one. And it's not this. Oh, wait. Maybe this one. Oh, so this may use the quadratic formula, which I think you get on the on the test. So it's 5. And we'll do, okay, fine. It's negative b plus or minus the square root of b squared minus 4ac divided by 2a. So that's 5 plus or minus. We have a 5 plus or minus. And we know that there's a 2 down here because a is 1, right? So immediately, it's not likely to be this one. And I would take a chance and do b because how is the only? I mean, this is the only way you're going to get a 5 over 2.
Yeah.
So
okay. However, we have to check that the solution is real. So you do have to evaluate.
Oh, that's right. You have to check if the solution is real. Oh, Seth, thank you so much.
Yeah.
So this is 25 minus 4 times, 4 times 5. Yeah, so it's real. Because 25 minus 20 is above 0. So, Seth, thank you so much. I would have gotten it right, but I would have been lucky.
Yeah.
Now, the question is, it's fine. I don't know. Look, I can even time it. I looked. Right? It took about 2 minutes to do that. Of course, I was talking. Someone could probably do it in a minute and a half. The question is, can you do this? Can you see the answer faster than a minute and a half being able?
Okay, so you want to time me? Or should we just do it?
No, let's time you. Okay, go.
Okay, 1. X equals 0 is obviously not a solution.
Okay.
And either it might be like no reals or maybe one of these. Okay. So I would calculate this and then observe that 5 has to be the product of the roots, and 5 also has to be the sum of the roots.
Wait. You said you would actually get this? You said you would actually calculate this?
Yeah.
So then let's see how
the sum of the roots here,
you're cheating.
The sum of the roots here is 5. And the product of the roots, well, is a quarter of the product of these two things, which is 25 minus 5, which is 20, plus the square root of 20. Which is okay, right? Which it should be 5. No. So the product of the roots, the product of the roots, the product of the roots is 25 minus 5, which is 20, right? But they're all divided by 4, which is 5. So the product of the roots is also 5. And so I would pick this as the answer.
Okay, the question is, which one is faster? First of all, you had to memorize something that isn't given. I believe the quadratic formula was given to you on the SAT. I guess we could check, but let's assume it is.
Okay, ladies and gentlemen, it's a good idea to memorize that.
It is a
in
good idea to know the
quadratic equation, the constant term is the product of the roots. Now, when it's a monic quadratic expression, the product of the roots for the expression equals 0. When it's monic, is the constant term, and the sum of the roots is the negative of the linear term, of the coefficient of linear term.
Wait, we're talking about memorizing.
Good idea to learn that.
Wait, we're talking about memorizing different things. I thought you were talking about memorizing the quadratic formula.
I memorized that, yeah.
Okay, fine. So Seth and I took completely different approaches. His approach required memorizing a characteristic of a polynomial where it's x squared plus bx plus c, and there's a 1 here. Okay?
Yeah.
So it turns out the product of the roots, the product of the solutions to the equation, this thing equals 0, R1 times R2 is equal to c. And then R1 plus R2 is equal to negative b. The problem, Seth, is that you have to sit here and multiply these two things together, which is not that easy to do. I mean,
no, it isn't, because they have the form.
It's 5
they have the form
2.
X plus Y and X minus Y.
I know.
Which is X, which you learn. The other thing you are expected to learn, factoring facts.
Yeah. Well, that's the difference.
Always factor the difference of two squares.
Right.
That's the sum of the things that are squared times the difference of the things that are squared. Right.
The question really comes down to, and I guess this is a personal choice depending on the person, is which one can you do faster? Can you do faster throwing stuff into the quadratic formula, or can you do faster 5 over 2 basically plus radical 5 over 2 times 5 over 2 minus the this, and then you know that this is 5 over 2 squared minus the square root of 5 over 2 squared, right? That's what we're talking about. So, but in order to do that, you first have to remember that the product of the roots has to be the negative of this term, right? You have to remember that.
This rule about the products of some of the roots is really, really cool. It's really, really cool because it's a special case of a fact, a very interesting fact about the coefficients of any polynomial of any degree in terms of the roots. When an nth degree polynomial actually has n roots, you could every one of the terms, every one of the coefficients. If it's an nth degree polynomial, the roots are the same whether it's in monic form or general form. So you divide by the coefficient of the high order term, get into monic form, and it's a really beautiful fact that each coefficient is plus or minus the sum of products of the roots taken a certain number of times.
Okay,
right?
So
that is a beautiful fact. It's really, really cool.
Okay, it's over everyone's head. You're up here now, Seth. You're up here. I'll tell you what. Why don't you, for people who are up here with you, why don't you state quickly what that property is and how you can look it up on Wikipedia? What's the name of that property?
What's the name of the property?
The relationship of the coefficients of a polynomial to its roots. And look it up on Wikipedia, and then you'll see what Seth's talking about. Yeah, I think it is a pretty cool thing.
Let's see. There's a name for it.
Yep. Well, it's the relationship.
The official name is some kind of symmetric functions.
Okay. Like we're up here now.
Fundamental symmetric functions.
Forget. Anyway, now let's go.
That's if you want to look it up.
Okay.
But look up roots. Say do a search. on DuckDuckGo
Yeah.
or Google for polynomials, roots, coefficients.
Right. That's what I just said. The relationship of coefficients of polynomials or their roots.
Yeah,
now,
yeah.
wait. In order to do this 5, don't you also have to add the 2 also to make sure that the sum of the roots is also 5? Don't you have to?
I
You have
did
to do
that.
both.
Yeah, I did. I said
Yeah,
I did
yeah,
that.
yeah. The question is which one's faster, and I don't know. People have to decide themselves.
Well, adding it is really, really easy because the square root of 5 terms cancel.
But what would happen if they reverse these two? Then you would have had to have done this one first, and you would have had to spend more time doing this one, rejecting it quickly, and then doing this one.
Yeah, sure.
Yeah, but that takes
maybe
time.
You would notice, your eyes would notice that there's a 5 here.
Yeah.
And there's a 5 here over a 2, but there's no 5 involved there.
Okay. But I'm just going to clear everything. But the bottom line is there a way? I don't know if there is. So let's see. We'll give Seth 10 seconds to decide. Is there a quick way just to look at this and just say, wow, okay, this is the answer? Like, you can't really take the square root of both sides, right? No. Okay. So then maybe you really do have to expand this thing and move everything over to make a regular old quadratic, where 0 equals some stuff. Notice I use a little trick. Nobody wants.
If you have a calculator, you could plot it.
Right. Good point. You could, if you have a calculator, you could go like this. You could go 0 is equal to 2 minus x squared plus 1 minus x, and make this a y. Plot this and see where it crosses. God knows what this thing does. See where it crosses the axes, and then you can approximate. But that takes time.
What another thing you could do is plot y equals x minus 1 and plot y equals 2 minus x squared. And see if one, what's going to happen is 2 minus x squared is going to be a parabola that is so 2 minus x squared at x equals 2 is going to be a parabola tangent to that, and x minus 1 is going to be that one, and you see if they cross.
Right, so that means you can reject this one and this one. They do cross. Yeah. And then
when you look at the plot, you could see for the bigger root, is it closer to this or to this?
Right. Yeah.
Square root of 21 is about 4 to 5.
Right.
So that 4 or 5 minus 1. 4 or 5 minus 1 is about 3 to 4 divided by 2. It's about 3.5.
Yeah.
About 2, 1.5 to 2.
Yeah, right. It was about say.
And this is also between, this is a little over 2.5.
Yeah, so not.
So I could look at, I could look at the numerical value of x there.
Yeah, you could do that. Do that. That's something to remember, is the graphical approach. You can just see, you can graph each of these and see where they cross. So
but then it takes time to type in those formulas.
It certainly does. It's better just to do either the quadratic formula or the way Seth did it. But this whole thing about the product of the roots is the C term of a polynomial, and the sum of the roots is the negative of the B term of polynomial, is definitely something you're going to want to know for the SAT, even though it wasn't required in this question. But I believe they do expect you to know that. Okay.
Well, let me show everybody where that comes about.
Oh, Seth, come on.
You have 2 roots, A and B.
Sorry. Go ahead.
Right?
Go ahead.
You just multiply it out. You get x squared. What happened?
I erased something on you. I'm sorry.
That. And then you have A plus B, the minus coming from multiplying these guys times X.
Right.
Plus, minus 1 squared times AB.
Right.
And so this is the sum of the roots.
Yep.
And this is the product of the roots.
Right. Okay.
Now, the thing is, the beautiful thing about it is that if you extend it.
No, let's not extend it.
Let's extend it.
Seth,
let's actually extend it.
Seth.
What do you get? Well, every term is gotten by picking one of the things from this guy, one choice, one of the terms from this factor, one of the terms of this factor, one of the terms of this factor, one of the terms of this factor, in all possible ways. And what you get is some product of x's, which gives you x to a power, times some product of the roots.
Okay.
That's how you get it. So every coefficient is composed of a particular power of x times the product of a particular number of roots.
All right. Okay.
That's where it comes from.
Okay.
And that's the really cool thing about it.
Yeah, it's very cool. Let's move on.
It's very cool.
Okay.
You say it's not cool?
I agree it's cool, but
it's
have
uncool.
Priorities. We don't want to look. We have
it
to
is
move on.
More cool. It is more cool than this ugly formula.
I don't know.
It's more cool than this ugly formula because there's no such ugly formula when the degree is greater than 5.
Right. Okay.
But this property is always true no matter how high the degree is.
All right. We love
and the ugly formula for degree 3 and 4. That's actually no for greater than or equal to 5. There's no formula, but the formulas for 3 and 4 are really ugly.
Okay. Well, anyone
they're
now
so ugly that they're not practical
now
to use.
everybody has graphing calculators, so you could figure out the roots of a polynomial quite efficiently by just graphing the thing and seeing where it crosses 0. Okay, ready? Let's move on. So, okay. So this is the answer. Let's see how they do it. They'll probably do it the way we did it.
We'll see.
We'll see. Either they probably did not use.
Make a bet.
They probably used the quadratic formula. Okay, let's see. That's how we answered the question. 4 steps. Oh yeah, you could see already. It's a quadratic formula. They moved everything over. They got the quadratic equation. They brought in the quadratic formula. They threw everything in. They didn't really have to finish. Because the only choices had a 5/2. There was only choice B, had this pattern to it. Oh yeah, plus you have to check for real roots. That's true, and then you go. Okay, so they just did the regular old standard way. Okay, so Eddie.
Yeah, so checking it for real roots meant that they evaluated this expression
right
here.
Yeah.
And figured out that it was equal to 5.
Right.
Exactly. Minus 5
25
squared
minus
20 is equal to 25 minus 20, which is 5. So they calculated that.
Okay, so that's it. Everyone, have a great day. Seth has a PhD in math. You probably noticed by now, and he's a professor emeritus.
So if they had, yeah. Yeah, okay.
Okay, we're done. Enough. Seth has a PhD in math. He's a professor emeritus at University of Albany. He also likes to drink tea. And I am SUNY Albany, and I'm Joel. I'm Seth's brother. I have a PhD in mechanical engineering. I also like tea. And please like us, dislike us. Give us comments on our YouTube videos, and if you have any SAT math questions, now you're being silly. If you have any SAT math questions, please email them to us at satmathquestions@gmail.com, and we hope to see you tomorrow. Take care, everyone. Bye-bye. Come on. Stop being ridiculous. Okay, bye-bye, everyone.